Welcome to this video about an introduction to dyscalculia. Developing number sense and mathematical language. Number sense can be seen as intuition about numbers and their relationships. It usually develops gradually as a result of exploring numbers, visualizing them in a variety of contexts, and relating them in ways that are not limited by traditional algorithms. When learning maths, we have to make connections between our non-symbolic representation of numbers, that is, our ability to see the difference between two sets of objects, and our symbolic representations of different number sizes, for example, 4 or 12 or 100,000. We first make sense of real things, such as counting and sense of number. We then use our understanding and language, both verbal and the symbolic language of maths, to begin creating abstract ways of describing what is happening when we do things with numbers. The symbols we use allow us to explain very complex ideas in a way that is more accessible than just words. But maths is a language in its own right. Success in maths. Success in maths requires visual and verbal abilities. Spatial skills for understanding shape, symmetry, relative size, and quantity. Linear skills for understanding the sequential and ordered symbols and representations found in the number system and algebra. Understanding of arbitrary symbols. Effective storage, access, and retrieval. Flexible working memory. The ability to combine creativity with rigorous mental organization. The ability to learn and apply rules, the ability to process text swiftly and effectively, and the ability to draw simultaneously upon a range of learning styles and preferences. These are not typical qualities of a pupil with specific learning difficulties, however committed and intelligent they may be. Difficulties with maths. Do all pupils experiencing difficulties with maths have a specific learning difficulty? No. Maths difficulties lie on a continuum. For some pupils, if maths is a relative weakness, for example compared with their abilities and perception of these things in other areas of the curriculum, this can cause some anxious feelings. Feeling anxious about maths itself can be its own barrier to learning. Pupils may struggle to develop their math skills for a range of reasons. This includes not having access to good quality maths teaching over an extended period of time. It's important to note that the development of mathematical skills is hierarchical and cumulative. That is, you need to grasp certain skills and concepts before you can learn others. Gaps in learning, therefore, can have a significant impact. Some pupils may have an identified or underlying speech, language and communication need, which is a high incidence SEN. It's possible also that a pupil may have poor vision or hearing, which has not been detected. Dyslexia and maths learning. People with dyslexia tend to have poor working memory, speed of processing, and rapid retrieval of information from long-term memory. These weaknesses will also affect maths learning. Around 2/3 of people with diagnosed dyslexia experience some difficulties with learning some aspects of learning maths. They may have specific difficulties with certain types of areas of maths such as fractions and decimals, long division and multiplication, multiplication tables, money and time, but not necessarily with number skills. Dyslexic pupils might also misunderstand some mathematical terms and language. They might have difficulties with sequencing and following procedures, and may forget previously mastered procedures very quickly. What is dyscalculia? Dyscalculia is a neurodevelopmental learning difference which can be described as a significant, persistent and specific difficulty in understanding number and number processes. This difficulty persists despite factors including high-quality teaching, an age-appropriate maths curriculum, and the pupil's other cognitive abilities and their broader academic potential. In a similar way that a lack of phoneme awareness causes dyslexic pupils to struggle with reading, a severe lack of intuitive number sense causes pupils with dyscalculia to struggle persistently and substantially with maths concepts and the acquisition of arithmetical skills. Even if they produce a correct answer or use a correct method, they may do so mechanically and without confidence. Research into dyscalculia is still in the early stages compared with dyslexia. It is estimated that around 5% of the population may have dyscalculia. What can you see here? And here? Barriers to learning. Dyscalculia affects maths, any subject, and any everyday task requiring the recognition of quantities without counting, estimating, ordering and sequencing numbers, use of number symbols, understanding of how numbers and amounts relate to each other. For example, 6 can be made from various numbers added together, or by doubling, or by multiplying. Recall of basic maths facts and processes, spotting of patterns in numbers, and the application of number skills to make generalizations and to solve problems, including with money and time. Pupils with dyscalculia tend to rely on following procedures which they may not understand, rote learning, and simple ways of working out answers, like counting on their fingers. Here is an infographic which provides a helpful overview. Difficulties you may notice. 1. Difficulty in remembering basic mathematical facts. Relies on tangible counting support such as fingers and tally marks. Uses the counts all method instead of counting on for addition. Makes mistakes in interpreting maths word problems. Gets mixed up with terms such as equal to and larger than. Cannot remember what different symbols mean. Recites the entire multiplication table to get an answer. Forgets the question before the answer can be worked out. Cannot locate a number on a number line without searching up and down. May have a similar difficulty understanding number square. Does not notice visual patterns, such as the 0 in 10, 20, 30, 40, etc. Cannot relate to visual representation of fractions or decimals, such as circles divided in half. Loses track when counting and reciting tables. Has difficulty in navigating back and forth, especially in 2s and 3s. Is confused about the difference between numbers such as 21 and 12. Puts numbers in the wrong place when redistributing or exchanging. Gets confused with division. Is it 3 into 6 or 6 into 3? And does not understand the importance of working left to right or taking the bottom number away from the top. Difficulties you may notice too. Scatters tally marks instead of organising them systematically. Finds rounding numbers difficult. Copies shapes inaccurately. Symmetry, tessellation and geometry present a real challenge. Cannot decide what arithmetical operation is required. Cannot build on known facts. For example, they may work out that 3 plus 4 equals 7, but not realise that therefore 4 plus 3 equals 7 as well. Poor setting out of calculations and of work on a page. Reverses numbers such as 9 and 6 and 2 or 5. Great difficulty with counting backwards. Finds it difficult to move from using concrete resources to abstract sums. Struggles to understand words relating to maths such as greater than and less than. Can have trouble telling left from right and has a generally poor sense of direction. Has trouble telling the time. Has trouble measuring things. For example, struggles to read scales and to double or halve quantities in an experiment or a recipe. Has a hard time grasping information shown on graphs and charts, and lacks confidence in activities that require estimating speed and distance. Difficulties you may notice. 3. Can't see that 4 counters are 4 without counting them. Finds it hard to count objects correctly. Poor one-to-one correspondence. Doesn't notice patterns in counting. For example, patterns for 2s. Counts in 1s as a default strategy. Doesn't group to help count larger numbers of objects. Makes errors when sequencing numbers. For example, 2, 4, 6, 8, 10, 11, 13. Has difficulty with recall of number bonds, for example bonds of 10 and doubles. Finds it hard to estimate. finds it difficult to understand place value and the role of zeros as placeholders. Confuses ty and teens numbers, e.g. 13 and 30. Finds it hard to learn or retain times table facts. Doesn't recognise that division is the inverse of multiplication. Doesn't link column addition or subtraction to place value and finds it hard to line up columns correctly. Doesn't link the place value to multiply and divide by 10, 100 or 1,000. Can't tell the time on an analog clock. Doesn't know coin and note money values. Misunderstands or doesn't retain maths language. Forgets previously mastered procedures very quickly. Has difficulty remembering the steps in a multi-stage process. Is easily overloaded by pages and worksheets full of figures. And has trouble coming up with a plan to solve a maths problem. This infographic provides a simple overview of difficulties associated with dyscalculia. Emotional responses, the impact on learner attitudes and behaviours. Because of these difficulties, the pupil is likely to feel overwhelmed and much less confident as a learner in some contexts, causing them to find it difficult to organise and start tasks, not offer to answer questions or to be slow in their response, not ask questions even when it's evident that they do not understand, and avoid maths activities and use diversion tactics. These difficulties may also lead to the pupil feeling very anxious about maths and any activities requiring the use of numbers. This is commonly known as maths anxiety, which naturally affects performance itself. Identifying difficulties. Identifying maths difficulties is a process rather than a one-off event, part of the graduated approach, assess, plan, do, review cycle, which includes the implementation of adaptive high-quality teaching strategies and, if necessary, intervention. Embedded within this cycle, information should be gained from a variety of routine sources, including the pupil's class-based work, staff observations, and progress data monitoring from regular assessments. Supporting this exploratory work, a basic dyscalculia checklist can be completed by staff and specific additional maths assessments can be undertaken to highlight gaps in mathematical concepts, for example, the Sandwell Early Numeracy Test and the Diagnostic Interview Number Sense. Screeners. There are various online dyscalculia screeners that can be used, which do not constitute a detailed assessment, but can provide an indicator of whether or not the pupil may have difficulties that are linked with a profile of dyscalculia. This includes, for example, Dynamo Maths Assessment, IDL Dyscalculia Screener, and Dyscalculia Screener GL Assessment. Multisensory concrete resources. It's important to ensure that maths teaching is multisensory, including the use of concrete materials and visual prompts. This includes, for example, number lines, number squares, Numicon, 5 and 10 frames, number rods, base 10, money, bricks, counters, times table grids, maths mats, problem solving grids, maths language cards, task boards, interactive displays, and individual whiteboards or notepads. High-quality teaching, part of routine lessons. These strategies can be generally useful for all pupils, including pupils with dyscalculia. Reviewing topic learning from previous lessons, highlighting and emphasising key maths vocabulary, pointing to mathematical items being referred to, repeating important information, chunking information, breaking instructions down into smaller steps, using colour coding and other visual cues, using diagrams, flowcharts, wheels, maps, and other graphical representations of information, demonstrating and modelling how to solve mathematical problems, asking pupils to tell each other what they need to do before starting a task and to rehearse and practice responses, explicitly demonstrating the link between maths and everyday situations, role-playing mathematical scenarios, and regularly summarising learning so far and linking it to prior learning. Reasonable adjustments. Reasonable adjustments are established for individual pupils as needed and are ongoing. Reasonable adjustments might include the following: providing the pupil with personalised practical resources to reduce memory overload, for example, key information on reference sheets, task plans, and a maths dictionary. Allowing for extra time to complete tasks and to respond in class and group discussions, and allowing extra time for controlled assessments, for example, tests. Adaptive, high-quality teaching strategies. Adaptive strategies are additional inputs provided by the teacher or TA under the direction of the teacher to supplement inclusive learning environments, high-quality teaching, and reasonable adjustments for the pupil. This includes additional scaffolding when required. For example, rephrasing instructions supplemented by verbal and visual cues. Reading through maths problems questions together to help extract the numerical information and work out the steps needed. Clarifying maths vocabulary for the pupil. Sometimes there is more than one expression for the same thing, for example, subtract, take away, and minus. Providing individualized prompts, for example by asking the pupil to repeat back to you the instructions or steps involved in a maths task, asking, "What do you think you need to do next?" Showing the pupil worked maths examples. Chunking a small multi-step task into further, more granular steps. Writing annotations in their workbooks, underlining, highlighting, and keywords, and encouraging the pupil to do this themselves. Explicitly pointing out patterns. Verbalizing and drawing maths word problems, and facilitating enhanced practical experiences using concrete materials and applying maths tasks to real-life problems that are relevant to the pupil. Games. Incorporating games into lessons can also be accessible and engaging for the pupil. For example, Connect 4, dominoes, board games that require working with number, for example, Snakes and Ladders, and Monopoly. Card games such as pairs with cards to help them match symbols. Online games, for example, Cool Maths for Kids, CricWeb, and Maths Playground. And apps, for example, Sundog and Finger Numbers. Interventions. Pupils with dyscalculia may benefit from time-limited group interventions such as First Class at number 1 and First Class at number 2, Success at Arithmetic, Talk for Number, and Numicon Big Ideas. Individual and personalised interventions include Catch-up Numeracy, Numbers Count 1 and Numbers Count 2, Talking Maths, Numicon Firm Foundations, Numicon Breaking Barriers, and Beat Dyscalculia. The following interventions can be implemented for small groups and individuals: Ideal Numeracy, +1 and Power of 2, Dynamo Maths, Number Shark, and Dyscalculia Toolkit. Assessments. For those pupils whose significant maths difficulties are clearly persistent and not responsive so far to the evidence-based interventions delivered over time, it is appropriate to consider a more detailed assessment. There are a range of assessment resources which can be used within schools, for example, the Dyscalculia Assessment and Trouble with Maths. It might also be appropriate to make a referral to a Level 7 qualified SPLD assessor who has expertise in the assessment of dyscalculia, or an educational psychologist, especially if the pupil's needs appear to be more complex. This is the end of this video. You can view more videos on this channel in the About series.